electricity class. This is Mr. Voigt. Um, I'm here to talk to you about the different kinds of circuits and how we represent those when we draw them. So the two types of circuits that we're going to deal with and that everybody deals with are series circuits and parallel circuits. So to get right down to it, a series circuit is a little bit simpler type of circuit. And how you define that is that there's only one path for electrons to flow in this circuit. So the way we represent that in a drawing is this is a very simple series circuit. This is a battery or direct current source. Sometimes they draw it here with what they call an AC power source or an alternating current power source. It doesn't matter which symbol they have. Either power source, you're going to do your calculations exactly the same. The other thing is there's competing theories as to whether electrons flow from negative to positive or positive to negative terminals on any power source. Doesn't really matter. The calculations work out the same. We are not going to get into that scientific debate or conversation at this point. Just understand, doesn't matter. You do it all the same. So, as you can see, it doesn't matter which way the electricity flows or electrons. There's only one path for the electricity to take. So this is a series circuit. Now there's a resistor here, and there's a resistor here, and then there's a total value of volts, amps, resistance, and wattage for the entire circuit. We also figure those same values at each resistor's point, or each impedance point. So I put over here R equals the resistance point. We also call that a voltage drop. Okay, the reason we call it a voltage drop is in any circuit, you're going to use up all of your voltage by the time you're through with your last resistor, like this. Your voltage is down to 0 as it's coming back into your source. So some of it gets used here, some of it gets used here, but it all gets used up. The thing is you don't know how much either place until you do these calculations. So whether you want to call it a resistance point or a voltage drop, doesn't make any difference. And these can be just a resistor, a point that we put in there to eat up some of the power and dissipate that power into heat. Or it can be something that does work that we want done, like a light bulb or a motor that runs. Okay, so those resistance points are one of those, they're doing some sort of work. A resistor just turns that electricity into heat. Okay, so the other type of circuit, I should mention this. This type of circuit, if I flip this over, uses these rules right here. When you're in a series circuit and trying to figure out the values or the characteristics like the volts, the amps, the resistance, and the power, you use these rules. They're logical. And we'll practice them in class, but you have to practice them also on the work that I give you in order to make them make sense in the long run. But you use series circuit rules. So now back on the back side, parallel circuit. Quite simply put, it's more than one path for electrons to flow. All the same issues apply up here, resistance point, voltage drop, all that. The difference is here, there's three paths for electricity to flow. It could go either way. In fact, if it's alternating current, it's going to go this way, then this way, then this way, then this way, right? You still don't know whether it's going positive or negative to positive. Again, doesn't matter. DC or AC power source. Path 1, boom. Path 2, boom. Path 3, just like that. So there are three paths. It could be 100,000 paths. As long as it's more than one, it's a parallel circuit. That's it. Those are the rules. And that's how you distinguish them. And these are the rules for a parallel circuit. And we're going to use those when we get to parallel circuit diagnosis and how to figure out these values in a parallel circuit. Now, I'm going to show you one more thing. There is and actually most electronics and cars and most things are a combination of series circuits and parallel circuits built into the same thing. And I represented that down here. You probably didn't notice, but there are two resistors in this, what we call branch right here. So this parallel circuit has three paths. Each one of those paths is a branch. 1, branch 2, and branch 3. And this branch has two resistors in it. If I cover up that resistor right here in this branch, and assume it's not there, we have a straight parallel circuit. It just, all the rules get used are parallel. Now, it's a little bit different. You don't need to understand why yet, but understand this is now what we call a combination or a series parallel circuit. They're two different names for the same thing. Now, in order to find out the values, the voltage, the amps, and so forth at these 2 points, we have to treat this branch. If we draw a line there and we draw a line there, we got to treat this branch as a series circuit from that point to that point. Notice there's only one path from that point to that point, so we can treat this as series. But it's within this larger framework, and so we also got to treat that in relationship to these as a parallel circuit. So this is called a combination or a series parallel circuit. We are not ready to have this explained to us. Just understand that it exists. Okay, that's all I had for now. Practice your circuit calculations. Thanks, guys.